You might already know that antibiotic resistance is a big deal, but do you know how many people die each year because of it?
Today, 700,000 people die each year as a result of antibiotic-resistant infections, and the World Health Organization forecasts that in 30 years, 10 million people will die each year as a result of infection that cannot be cured with antibiotics anymore. Antibiotics are wonderful drugs. They are able to kill bacteria without damaging the human cell, which has allowed them to save millions of lives since we began to use them. The first one, penicillin, was discovered by Alexander Fleming in the beginning of the 20th century. Yet, only a decade after its first use, antibiotic-resistant bacteria had already begun to raise concern among scientists.
But how do antibiotics actually work? There are small molecules which can basically alter the bacterial DNA synthesis and therefore stop its growth or destroy its membrane. Let's take an example of someone infected with the bacteria called Pseudomonas aeruginosa in its lung. If we introduce an antibiotic near those bacteria, it will quickly kill most of them. The patient starts feeling better. However, some bacteria did survive. As in any species, there are differences between bacteria. Some bacterial populations have evolved to be resistant to antibiotics. This is due to small differences between bacteria's genome, called mutations, which orchestrate the natural selection dear to Darwin. In our case, a small pump helps the bacteria to eject antibiotics before they can do any harm. Usually, the immune system will take over and kill the remaining pathogenic bacteria. But what if it doesn't? Well, this lonesome bacterium will grow again, giving to some of its offspring the ability to resist to this antibiotic. At this point, the patient starts feeling sick again. The doctor will once more prescribe him the same antibiotics. But it is not effective anymore. The doctor will have to prescribe another antibiotic, more efficient this time. Here again, it might not be 100% effective. If the bacteria manages to resist to this new antibiotic, it and its offsprings will be multi-resistant. If this process is repeated over and over, it creates resistant bacteria to all antibiotics. They cannot be killed, they cannot be stopped, they are superbugs. Those exist and they are already killing hundreds of thousands of people each year. Superbugs are therefore a direct consequence of antibiotics use. And the bad news is, we are using them more and more, whether it is for treating humans or in order to keep our livestock alive long enough. In some countries, up to 80% of the antibiotics are used to prevent infections of livestock.
Yet, all hope is not lost. Scientists actually got more tricks up their sleeve than just antibiotics, and one of them is phagotherapy. However, we cannot rely on those alternatives alone. We have to change our habits and reduce the use of antibiotics worldwide. For this, our society will have to find new methods to prevent ineffective drug prescription. Our team is working on a diagnostic device able to, among other things, precisely identify a pathogenic bacterium and to check if this pathogen is antibiotic resistant or not.